So this is the 42nd session on relative velocity. So in this video we will discuss numerical problems on relative velocity problems between two mutually translating frames. Okay, so from starting from this video, all the videos that will come subsequently, they'll be based on this relative velocity problems for mutually translating frames. Fine. So I'll write down the basic equation for it. So suppose, just a minute. Suppose F and M are two reference frames. F and M are two reference frames. Frame M translates with respect to frame F. So M translates with respect to frame F. VMF is the velocity of frame M with respect to frame F. P is a moving point. P is a point which is moving with respect to both the frames in general. Now the definition of translating frame has been discussed in great details in the introductory videos of this relative velocity chapter. Around fourth or fifth video of relative velocity, you will get all the details on translating frames for definition of translation, all the other concepts of translation. They have been fully discussed in the third or fourth video of the relative velocity. Okay, so you can go and check it there. Okay, so P is a moving point. So VPF, velocity of P with respect to frame F at time t, is equal to velocity of P with respect to frame M at time t plus velocity of frame M with respect to frame F at time t. So this is the formula which will be used for mutually translating frames. Okay, so all the subsequent videos which we'll get will be based on this formula. All right. Now what we'll do that we'll categorize the problems depending on out of these three quantities which is known, which is not known. On that basis we'll categorize it. Okay, so we'll divide these successive videos in following types. Okay, first we'll see this case 1. In case 1, VPF and VMF are known, totally known. Magnitude and direction both are known. So for vector VPF, its magnitude and direction both are known, double tick. And for velocity of M with respect to F also, its magnitude and direction are both known. We have to find, problem will be based on finding the magnitude and direction of VPM. To find VPM, that is the question mark. Fine. Okay. This is case 1. All right. I'll wrap this. Okay. Then we'll take up problems on case 2. Case 2 is this. In case 2, VPM is known in magnitude and direction both, and VMF is also known in magnitude and direction both. Problem will be based on finding VPF. So main we have to determine the magnitude and direction of VPF. This is problem of case 2. Fine. Then we'll take up problems on case 3. Case 3. In case 3, VMF is known completely in magnitude and direction both. VPM only magnitude is known, direction is not known. And VPF direction is known. direction of VPF is known, and magnitude of VPM is known. So generally in case 3, problem will revolve around finding the magnitude of VPF in most of the cases. Okay, so this is the case 3rd, and case 4 is all the remaining cases which they will come in case 4. All right. And case 4, all the other remaining cases, they will come in case 4. All the other remaining cases, they will come in case 4. All right. See, in case 1, case 2, case 3, we can outline a general procedure for solving such class of questions. But in case 4, nothing definite can be said. You have to read the question and then decide how to solve the case 4 problem. That you have to decide after reading the question itself. But in case 1, case 2, case 3, we can more or less outline a general procedure for solving such class of relative velocity problems. Okay. So I'll demonstrate in examples which come. Okay. So in this video, we'll discuss the problems on case 1. We'll take up numerical problems on case 1. All right. So one more thing which we have to take into account for all these 4 cases, we have first to, for all these 4 cases, common steps which are valid for all these 4 cases. First step is that we identify the object under consideration, which moving object is being under consideration. So identify the object under consideration. Then second step, identify the frames under consideration. Under consideration. Third, write down the vector relation. Write down the vector relation. And then fourth step, after writing the vector equation, we observe which quantities are known and which quantities are unknown, so that we can know which case the problem belongs to. Decide which problem, which case the question belongs to. And after that, once it has been decided which case the problem belongs to, then accordingly we proceed to solve the problem by applying the procedure for that particular case. All right. Now I'll grab it. All right. So now I take up the problems on case 1. So this is the 42nd session on relative velocity, alright. So case 1, I write down the vector equation, which is common to all the 4 cases. So that vector equation is this: VPF equal to VPM plus VMF. As stated just now, VPF complete information is there, magnitude and direction both. VMF also complete information is there, magnitude and direction both. Problems revolves around finding the magnitude and direction of VPM. So from this vector equation we can see that VPM is just equal to VPF minus VMF. That is, we can write VPM is equal to VPF plus minus of VMF. Minus of VMF means reverse of vector VMF. Same magnitude as vector VMF but direction opposite to VMF. So reverse and add concept. Reverse VMF and add it vectorially to VPF, we get VPM. Okay. And then to find this VPM, we use the usual parallelogram laws of vector addition. That is, we parallelly shift the tails of any of these two vectors so that the tails coincide. With these two as adjacent side, we complete the parallelogram. We draw the diagonal of this parallelogram through the common tail of these two vectors. That diagonal represents VPM, and so we can determine VPM, its magnitude and direction both. Fine. This is the method to be followed while solving problems of case 1. All right. That's one thing I would like to state again, that we will not try to solve a problem this way: rainman problem, aeroplane air problem, river boat problem. No. We will divide the problem in various cases and then we will take up that problem. Okay. So it is possible that in one particular case only we are having all problems on rainman problem, river boat problem, aeroplane air problem in particular case. So in this way we will tackle. Okay. We will proceed in this way. All right. So now this I have written down. Okay. So I will take up the question. Fine. So example 1. We will take a first example. Okay. I will write down the question. Raindrops are falling vertically downward. Raindrops are falling vertically downward at a speed of 4 km per hour with respect to ground. A man holding an umbrella runs rightward at a speed of 3 km per hour with respect to G. G meaning ground. All right. At a speed of 3 km per hour with respect to ground. So now we have to find two things. Find first speed of raindrop with respect to man. With respect to man. And second, at what angle with the vertical should the man hold the umbrella axis so that he protects himself from raindrops in best possible way. Okay, this is the question. All right, fine. I'll grab it. Okay. So now first what we do, we identify the frames objects under consideration, the frames under consideration. So first of all, what is the thing which is being observed? Raindrops. So object under consideration is raindrops, which is denoted by R say. Then the frames are man is a frame, and say. And F is ground. G say. Alright. Now I write down the formula for translating frame. VPF equal to VPM plus VMF. Instead of P we have R. F we have G. VRG barabar VRM plus VMG. VRG is equal to VRM plus VMG. Now VMG complete information we are given. Complete information is given for VMG 3 km per hour rightward. VRG also complete information is given 4 km per hour in vertically downward direction, and nothing is specified about this. So we have to find this VRM. So it's a problem of case 1, you can see it. It's problem of case 1. Alright. I'll grab it, okay. So now, what we have to do, first thing we have been asked to find the speed of raindrop with respect to man. That is the magnitude of VRM, okay. So in first part of the question, we have to find the magnitude of VRM, which is nothing but the magnitude of vector VRM. That is just the magnitude of VRG minus VMG from this vector equation. That is just the magnitude of VRG plus minus of VMG. Okay, so we have to add these two vectors. Okay, now we have to add these two vectors, and so magnitude you can get directly. You can see it's root under VRG square, that is 4 square. VMG is 3 km per hour, minus VMG is also 3 km per hour. Magnitude plus 2 into 4 into 3, and angle between these two vectors. VRG is rightward, minus VMG is downward. So, sorry. VRG is downward, VMG is rightward, minus VMG is leftward. So, angle between VRG and minus VMG is 90 degree. Cos of 90 degree. Cos 90 degree is 0. So, this becomes 4 square plus 3 square, that is 25. That is equal to 5 km per hour. One answer has been obtained. Alright. The speed of raindrop as seen by the person will be equal to 5 km per hour. That is the speed of the raindrop with respect to man. 5 km per hour is the speed of raindrop with respect to man. I'll rub this, okay? Now part B of the question is, at what angle with the upward vertical should the person hold the umbrella axis so that he protects himself from the raindrop in the best possible way? Okay. See, in order that the person protects himself from the raindrop in best possible way, he should hold the umbrella axis along the direction of the velocity of rain as seen by the person. Okay. If person sees that the rain is coming towards him in this direction, he should hold the umbrella axis like this. If the person observes that rainfall is falling on him from this direction, he should hold his umbrella axis like this. So in order to best protect himself from the raindrop, the person should align his umbrella axis along the direction of relative velocity of the raindrop as seen by the person. That is along the direction of the vector VRM. Okay. So to protect himself from the raindrops in best possible way, he should align his umbrella axis along VRM. Okay. So that is the velocity of raindrop as seen by person. Fine. So now we have to find the direction of VRM with the upward vertical. So for that we have to draw the vector diagram. Okay. Now this I'll draw, alright. So first we have to draw the vector diagram. From that we'll draw the arrow for VRM, and then using geometry we will find the angle which VRM makes with the vertical, and that is the required angle. Okay. So as I just now wrote down, VRM is just equal to VRG minus VMG. Okay. This is just equal to VRG and reverse of VMG. Okay. So now VRG is what? 4 km per hour in downward direction. This is the arrow for VRG. This is VRG 4 km per hour. VMG is 3 km per hour rightward. So minus VMG, that is reverse of VMG, is 3 km per hour leftward. We have to add vectorially these two vectors. So we shift the tail of this so that the tails of these two vectors coincide. This is the vector minus VMG. This is also 3 km per hour. Now with these two adjacent sides, we complete the parallelogram, which is a rectangle in this case. We draw a diagonal of this parallelogram through the common tail of these two vectors. This one. This is the vector VRM. Now this makes an angle of theta with the downward vertical. This theta we have to determine. The person will see the raindrop coming towards him in this direction. So tan theta will be equal to how much? Tan theta will be equal to this by this right angle triangle. This is 3, this is also 3, this is 4. So tan theta is 3 by 4. So it is seen that theta is equal to tan inverse 3 by 4. This is the required answer. Now tan inverse 3 by 4, tan inverse 3 by 4 is a well-known angle in physics. This just comes out to be 37 degree. Okay. So this is the required answer to part B of the given question. Fine. So this was the first problem of case 1. Alright. This was the 42nd video. In the next video also I will take up some more problems on case 1. Okay. Then I will pass over to case 2, then case 3, then case 4. And then chapter on relative velocity will be finished. Okay. I think there will be around 60 videos on relative velocity. 60 videos. If you go through all of these 60 videos, you will have a complete command of this chapter on relative velocity. And I am sure you will crack the mains, advanced and NEET exam for physics. Okay. I don't think there is any doubt about it. Alright. Fine. So I close this here. Okay.